Hello, Internet. Today we are going to try and make ourselves a Cloud SQL instance of, let's say, Postgres or MySQL on Google Cloud, and we'll try to make some function calls from, I don't know, let's say Cloud Functions. So let's actually try to make a full-on transaction with a public API through Cloud SQL. So without further ado, let's get to it. I have nothing provisioned for this. We'll open PyCharm on an empty initialized project, and we'll use Terraform to actually provision everything here. So yeah, let's just go with opening this file and calling adding versions. Let's add a versions.tf file. And this is going to be our Terraform module. And within it, we would need a Terraform block, and we'd like, is that the syntax? No, yeah. So, backend, yeah, we'll definitely use a backend, a GCS backend, not a local backend. So GCS backend, and our bucket would be, what's the name of the bucket? I failed to remember. It's storage, cloud storage. And they do have a personal bucket just for that. So SUF's the infra state. Awesome. So that's going to be that. And we'd need cloud SQL POC. And then Terraform state. Yeah, seems fine for the backend. And we'd need a provider, which would be Google, but let's aim for the actual Terraform version. So Terraform Google provider. Version 5.7.0. Let's just zoom in on that so you'll be able to read the docs with me as well. So 5.7.0. And we can now run Terraform init. This should initialize our backend, and yeah, okay. So we should already see some empty state in Google Cloud Storage, and our project now is going to be, I think SUFS Infra is the actual right project. So we do have SUFS Infra. Yeah, so kudos for Copilot for either remembering some context about me, or maybe actually just completing things just by this string here in the context. So we've got ourselves an initialized provider, and we'd like to provision ourselves. First of all, we need Cloud Compute and Cloud SQL APIs. So let's just add those quickly. So it's going to be Google Project Service, not SQL admin, but we need the compute API. Is that the right way to actually do that? I'm not sure. I remember it's service, but it's Google Service. Google Service Account, Google Compute Service. I believe this is the right thing. Then we need something in the lines of, yeah, we don't need to define the project because we're in the Google provider already. So yeah, compute API. If it's actually initialized, we can also skip that part. So let's just switch context to the infra itself. And this bucket is definitely, what? Oof, infra state. Ooh, that's a dangerous bucket. Yeah, let's delete that bucket. it has one less character in the name, and it's definitely not the one that we want to use. Yeah. And let's see, the Compute Engine API is enabled, so we don't need to do anything about that. And what about the SQL API? We need to just create an instance. So yeah, we can just do that with and no APIs. We don't need to enable any Google APIs. So Google SQL database instance, and we can just call that, yeah, Cloud SQL POC, and database version. We will go with Postgres, I don't know, 15. What's the latest? Is it 16 already? Postgres 16. I'm not sure what's the way to provision like the patch version of Postgres here, and we're just going to wing it and hope for the best. What we would like to do is, first of all, we need to like configure the actual machine that it runs on. So count just one, definitely nothing fancy here. Connection, clone, dynamic, lifecycle, provisioner, project. I'm basically looking for how do I actually provide it with less or more storage. Seems like I'm missing an important thing. We could actually just go for the docs. Maybe that would be useful. This is actually a point of ranting. Like, I think Terraform, the Terraform plugin and the JetBrains IDs could have been much nicer if it would have just linked to the docs whenever you command click or control click any string there. So if we actually go to the Google provider and go for SQL resources, Google SQL database. Ooh, so okay, so we do need an instance, not the database itself, not the database itself, because we definitely do not. Okay, so second, interesting. Okay, we have something to read that, but anyway, the database instances, which are basically the machine and the executable of like Postgres or MySQL running, and then there's the databases, which can be multiple databases that are with the same like in the same like multi-tenant you can have multi-tenancy in the same instance. That's the only thing I wanted to say. So we've got we can also provision an SSL certificate. That's nice. We might actually want to try and aim to do that. For more information, see the JSON API or the official documentation. Notes on Google SQL database instance. Second generation instances default to root at %user with no password. This user will be deleted by Terraform on instance creation. You should use Google SQL user to define a custom user with a restricted host and strong password. On newer versions of the provider, you must explicitly set deletion protection false and run Terraform apply to write the field to state in order to destroy the instance. So we definitely want to actually remove that deletion protection from the get-go, because this is just a dumb database that we just want to like play around with and destroy in about an hour or so. So we've got ourselves a Cloud SQL POC instance with Postgres 16. Hopefully that's valid number. Okay, so we've got a settings block. So that's the one I missed. And here we'd like to actually figure out which kind of DB. I think DB-F1 micro sounds like the most fucked up and smallest instance you can have, but we'll definitely find that out here in the docs. So shared CPU machine types are not covered by the Cloud SQL SLA. Okay, very cool. Good to know that small instances are not covered by the Cloud SQL SLA, which I don't know what kind of SLA agreement they're trying to guarantee here, but not covered by that. Basically, you can have outages and you cannot complain to Google if you have outages if you cheap out on the compute. That's good to know. And I do know that Google are quite cheap in terms of like they actually their SLA is shit when you don't pay. When you don't pay a lot. Like Cloud Run, I've had small outages on machines like when I already provision 10 machines. Like I let them to basically max out the autoscale, and they have failed me with like being unavailable. So I do believe them when they're saying it's not covered by the SLA. Billing on partial seconds, that's not interesting so much. And we can just move on and just use the basically DVF1 micro because we don't care about that. We get 600 megabytes of RAM. Wow, 3 terabytes of storage maximum capacity. That's more than enough. And we are paying an hourly fee of 1 cent and 5 decicents or something. I don't know. How would you? 0.0105 dollars per hour, basically. Which is not free, and we are going to, I don't know, pay a few cents. That's all right. Okay, so that's our instance. We can say count something. Name, count index +1. Okay, that's not interesting. Boot disk. So boot disk is an interesting thing. Is that in the same settings block? So this is in another block. So why do I not see the boot disk? Google Compute instance. Interesting. So granular restriction of network access. Content on-prem. Interesting. Okay, so you could provision an instance externally and then somehow connect these. I'm not sure how, but here we've got like, I don't know. Okay, so this is like networking stuff that I'm not interested in at all because we're just going to connect to that database via an internal socket, hopefully, and not with an actual public IP address. Okay, so Google Compute global address, compute service, blah, blah, blah. IP configuration, IPv4 enabled, false. Yeah, definitely. So what else do we have here? Oh, this is a big block. So availability type. I don't know, the cheapest. I don't care about that at this point. Availability type. And we actually, let's just zoom out for a little bit just to, we'll have actually more text because the plugins are shit. They won't let me know, huh? I'll need to read that in the docs. So let's just zoom back in so you will have a better view, and let's go back to actually figuring out this thing. So within our IP configuration, we can go for that. We don't need a private network because there isn't going to be a private network. And let's figure out. Okay, so apparently Postgres 15 is the latest one that they do support. So we're not aiming for 16, apparently. That's all right. Replica root password required for MS SQL. Or should I say squeal? If you don't watch the Primeagen, then I do recommend you do that at some point. Availability. So we've got regional and zone. So I think regional, I think zonal availability is enough for us. We don't need anything fancy. because this is again just the one database that we're just going to play with. Can we figure out what else do we need? Specifies if connections must use Cloud SQL connections. So connector enforcement, yeah, we are aiming for only Cloud SQL connectors. So enforce, was that in like in a connector? The settings block. We are within the settings block. Connection? No. You know what? Never mind that. Let's just figure this out as we go along. Let's try to provision this one and we'll see what else happens. Disk. That's the only thing that I want to like first provision in a sane manner. So disk size. Yeah, that's the one. So disk size is going to be 10 gigabytes, which is the smallest thing that we can do. And we definitely can just use the HDD type. So disk type is going to be the HDD. PD is for persistent disk, and SSD is SSD, and HDD is hard disk drive. Pricing plan. Is there an option that's not per use? Only can be per use. That's amusing. Time zone. Why do we need time zones? Oh, that's a terrible, terrible thing. All right. Okay, this apparently runs very deep. We don't need all of that. We can just provision the database on top of the actual instance. So let's do that. So resource, SQL database. And the name of that database is going to be, well, sure, let's just call that maybe default DB. Something like inconspicuous. What other settings can we support here? So we've got collation. So collation is for MySQL. Charset is for MySQL. Anything else? Probably not. Shouldn't be a lot to configure for a specific database. We do need users. So let's figure out what do we do with an actual user. Maybe within the settings block, user labels, that's not interesting. Root password. So the root password is going to be random. Is it like a provider random? I don't recall. We do need to actively specify that. So HashiCorp random. Um, 351. And we need ourselves a resource, which is random password, literally, which is going to be the root SQL password length. I don't know. 20 characters is fine. We don't need to know that password, as far as I know. And that password is going to be now computed here. So random password, root SQL password, and result. This is now going to be generated and owned by Terraform, and I do not need to know the actual secret value, which is quite nice. Enable private path for Google Cloud Services. Not sure what that means. Let's just leave that like that. Okay. Cell phone plan. Let's see how does telephone handle that. It says inconsistent with blah 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 because we've added the random provider. Now we can plan. If you are not familiar with telephone, missing resource instance key. SQL database default name. Because SQL database instance has count set, its attribute must be accessed on a specific instance. Interesting. So we could do a for each. I think that is the case here. So we can do for each something. This is the first time I use a for each block in a telephone. So this is going to be wild, I guess. So for each, let's figure out how do we do that. For each Terraform. I'm sure there are like crazy things that happen when you do for each in a declarative block. So for each, a group, another group, East US, West US. How do we use for each to set? Okay, so apparently we have a function that can take to set and use our instance, which is this one. Default. How is that working? Each block, each key, each value. So let's figure out limitations on values used in for each. For each cannot be used by the result of impure function, including GUID, bcrypt, timestamp. Yeah, okay. Functions that are basically non-deterministic, more or less than I think pure. But sure, you can call that pure functions, whatever. Chaining between resources. Yeah. Okay, so we do need somehow to we need a way to extract the proper instance name. Like, by the way, we could have like completely hacked away with just adding, I think, like a 0 here, and that is going to be okay. But do we want to actually do that? Probably not, because, well, we do want to know how to do that at some point. So let's learn how to do a for each loop in Terraform. So for each AWS VPC dot under example. So one gateway per VPC. Okay, so it seems like we can just use each value ID. Okay, so that's kind of nice. We can just go with that. And then so we don't need to do anything fancy. So for each, and then instance each name, value, name. I think that's the way to do it. If I understand, this is the sequence. So it says for each of the sequence, each value, we just use the name. That's how we provision an arbitrary amount of databases, or exactly. Wait, it says invalid argument. Interesting. For each key, value is unsuitable. For each requires argument must be a map, set, or a set of strings. You have provided a value of type tuple. That's okay. So we do need to use the to set function here. And that is going to be a set of databases, not a tuple of databases. Okay, I can work with that. And apparently is a tuple of one element. That is correct. Sensitive values or values derived from sensitive values cannot be used in for each argument. If used, the sensitive values could be exposed as a resource instance key. But this is what I aimed for. So that's the resource name. That's the actual instance here. AWS VPC for each VPC. And this one is going to use, I don't know, variable VPCs, app object string. I am confused. So VPC IDs. How do we do that? Never mind. This is just noise. Let's just move on with our lives. Let's access only the first element here and continue on with our lives with no using for each. Maybe we'll add another video just for that. Okay, so this is going to provision also. We are planning to provision an instance, a database, and a random password for that database. And if we run Terraform apply, we are going to be hopefully quite happy. And we'll say yes. This is going to be releasing log state, and it says failed to create instance Cloud SQL POC. At least one of public IP and private IP or PSC connectivity must be enabled, invalid. Interesting. So let's go back to the SQL provider, to the Google provider. Google. And then SQL. Where are the docs? I want the docs. Cloud SQL. And connectivity. So Google Service Network Connectivity, private VPC connection. Do we want to provide a VPC? I think that could work. Are we in Google Beta? Right. Never mind. So address type. Wait, where's the database itself? So instance. IPv4 enabled private network. So we either enable a private VPC network or nothing, or an IPv4 network. So let's go with the VPC because apparently we need one. Feeling like this is a waste of time, but this is the point. We are attempting to provision ourselves a Google database on the cloud. So Google network, Google Compute Network, and we're going to call that default VPC. And its name is going to be default VPC. Anything else that we need to do here? I think no auto subnets. I think this is enough, probably. Let's just figure out what they define here. So they said Google Compute Network, private network, .id. The network itself is just the name private network with nothing fancy attached to it. So that's the one for us, and we are aiming for our default VPC here. And we can try to apply again, and we'll figure out whether this actually succeeds or fails now. By the way, this is Terraform for you, like basically trying guess your way, and this is just dependent on how familiar you are with the tool and the environment you are deploying to. I don't think this has ever been a nice experience. Yeah. Okay, we've got a VPC. Now we're waiting for the database, and then it says valid request, service networking not enabled. And it says, wait, what? Enable private path for Google services, IPv4, private network, networking. What else do we need to define here? Correlation, backup configuration, division policy, pricing plan, user labels, maintenance window. Nothing interesting here. Let's try to copy the let's try to copy out more things around that area. We've got a DB name suffix. Oh, that's actually a nice thing to maybe add while we haven't still had ourselves we haven't provisioned the database. So DB name suffix, then we can just patch that here. Yeah. This is just going to be now, yeah, Cloud SQL POC is still nice. So our instance depends on network private VPC connection. Interesting. Do we need to actually do that? Oh, we have not provisioned ourselves VPC the networking connection. Maybe that is the problem. So this is going to be default VPC, and this one is going to be a private IP address. And this private IP address, where does it come from? Google Compute Global Address, private IP address. Okay. And this is going to be default VPC and private VPC connector. And everything else should now be okay, I think, probably. The private VPC connection. I believe this is it. I don't think we have anything else to add. Let's try to apply that again. By the way, the telephone init again, apparently. Google Beta. Why do we have Google Beta? That's not true. Yeah, we definitely do not want Google Beta here. There's no need for us to use the beta provider when we're just using like normal stuff. So let's re-init again. And this should have at least removed, hopefully, the Google Beta provider. And we can now try to apply again. And let's just run that. I do really like the fact that Terraform allows us to service disabled. Service networking is disabled. So we can just go to this page and hopefully Google will just claim we can click this API and things will automatically start working. Fail to delete one bucket. Why did you fail to delete the bucket? It now just did. Okay, interesting. Terraform apply. I should just add the dash auto approve. Like I'm not doing anything important here, so there's no need to go slow. But by the way, edition enterprise. I wonder what other editions are there, because enterprise sounds expensive. So while Terraform is provisioning in the background, which you can figure out in a minute. Oh, I now figure out. I now see that. Yeah, screen capture stopped for a while. So let me recap for the past few minutes what has happened. Nothing important or fancy. We have tried to provision the database. It has failed multiple times. I don't know how much of context do you need actually to catch up here, but really nothing interesting happened. And hopefully I will just cut it out in the edit room. While that is happening, let's try to create a cloud function and connect it to our imaginary cloud SQL connection. So let's just do that, I think, manually, because Terraform is just too damn slow for creating a cloud function. So cloud function. This is going to be an unauthenticated, insecure API that allows anyone with the URL to write into this database. I'm not caring about auth right now. I'm caring about the integration. Let's enable all the required APIs. So second generation, definitely function. That's going to be DB writer. It's going to be in US Central 1. We are going to allow unauthenticated invocations, and we can definitely use the lowest amount of CPU, because we're just going to open a SQL connection, try to write something to it, and then back out. Concurrency 1, timeouts 10 seconds is more. 10 seconds is more than enough. Auto scaling 0, just 1. Runtime compute service the generic account is fine. Next. And enable. I'm wondering why didn't they just ask me for that API as well, because looking at cloud functions is nice, but provisioning them is a bit nicer. We are going to use Python because I'm trying to be as conservative as possible with the amount of effort that I'm doing. So we've got our inline editor. We are going to use, I don't know, async PG would be fine. And we are going to basically copy stuff from async PG, because that's going to be more than enough for now. Yeah, definitely nothing fancy here. Ooh, interesting, because we cannot use async PG because I think Cloud Functions do not support async, if I recall correctly. Or do they? Does the function framework support async? Write HTTP functions, async. Functions framework, async IO. Functions framework for Python. No mention of async anything, which is interesting. Do they not support async IO? Is it possible to use async IO in Google Cloud? Import async IO. Just need to run the async functions from your main deployed function. Here you would deploy, yeah, but that does not allow concurrency, because, well, is that a thing? Because that means that you have one event loop per request, which is basically just one thread per request anyway. I don't believe this is actually possible. Not like that, at least. So let's just write that more explicitly. Google Cloud Functions async IO, async Python. Yeah, this is going to be a terrible, terrible. Yeah, so async, like screenshots of code is definitely not the way to go. Okay, so never mind about that. We'll just use not async PG, but we'll use just directly psycho PG. Psycho PG. So Psycho PG 3, that's the latest one. Asynchronous support. Where's the quick start? Just want the simple code. Give me the simple stuff. Getting started. Thank you very much. Installation. Yeah. Where's the like? Here's the connection. Here's the select one thingy. Let's just zoom in on that. Maybe basic module usage. That's the one. Import psychopg with psychopg connect. DB name equals test user Postgres as connection. Connection cursor create table. Yeah, that's the one that we actually want to use. And okay, cool. So this module name is psychopg, not psychopg 3. That's all right. What's going on with the database? Still creating. Wow, damn. Sometimes Google is just slow. I think I do need to give like AWS a test drive at some point. So our requirements is going to be that's going to be psychopg 3. Is that the way to install that? Figure out installation. Pip install psychopg binary, definitely. We are not going to meddle with trying to compile that crap on what's the name on cloud on the Cloud Function instance. And our import is going to be very, very, very suspiciously similar to the getting started guide here. So basic module usage. We are going to import that. And in the hello HTTP endpoint, we are going to, first of all, delete everything fancy here because we don't need any of that. And we are going to split the tab and just copy stuff right there. So, but we do not want to actually, first of all, we need to figure out to do like this one. We don't know like how to connect yet. To do, how do we connect? Question mark. And create table if not exist. Is that the right term? I'm blanking, but we can just actually let's just use ChatGPT for like the SQL syntax because, well, don't care about anything else. Close sidebar and please add is only create the table if it does not exist. If not exist, okay, exists. And I wonder if I would have broken stuff if I used not exist. Yeah. And tab. No need for. Oh, yeah, this is actually important. So create table if not exist. ID serial primary key and integer data text. Insert into blah, 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 blah. No SQL injection, that's all right. Apply complete. So do we have an instance? I think so. If we actually refresh that, that should now show us one randomly generated, like one randomly named SQL Cloud SQL instance. It has a private IP address, it has an associated network, blah, blah, connection, and the connection name. And we are going to try and use that in a minute with our Cloud function. So, how do we connect? That's the actual problem. I think, by the way, that we can also have that as part of like the one cold start. And then once it, oh, never mind. You know what? Let's just not figure it. Let's not optimize. We're not here to do that fast. We are here to just make that work. We are going to figure out fetch form test. Let's just limit that to 100 lines because, well, that's going to, well, oh, so it's already fetch one. Okay, that's all right. That's important because we are going to insert that every time we call the function, and I don't care about that so much. And actually, instead of printing the record, or we can print the record, but we can also, after committing everything, we can return the record, the last record that we iterated on. I believe this is it. And once we have disconnected from our database and we have committed everything, we can return our record, which will be something. And just to make sure everything is a string, because I do not care about serializing the data from the database, but let's just cast that to string and hope for the best. And let's just figure out how do we connect the Cloud functions to our SQL database. So Cloud SQL connect Cloud function. Connect from Cloud functions. So Cloud SQL instance is described. We've got the instance name, and we can maybe try and private IP, Unix socket, Cloud SQL connector. That's the one that we aim for. So from Google Cloud SQL connector, apparently we can just do that, and that does magic somehow. Damn, that's going to be quite more cumbersome than I thought. Warning, Linux-based operating systems have a maximum socket path length of 108 characters. The total path exceeds that length. You cannot connect from Cloud functions. That's such a weird limitation. So we do have a private IP. That might be nicer. So this is just SQL alchemy stuff. That's not interesting because we're just using PsychoPG directly. But we do need to pass here the connection string. So public IP default. We do not have a public IP. We do have a private IP. But that's a TCP thing. And we do not want to actually do that. So yeah, we are definitely aiming for the Cloud SQL connector. Okay, so let's just copy that crap here because apparently we don't deserve any nice things. And let's figure out how do we actually do that. So we have copied the connector and IP types import. PyMySQL, that's not interesting because we are using PsychoPG. And we do want the connect with cursor. And how does that look? So our connection is going to contain the instance name, which apparently is just going to be the instance connection name. Who's passing the instance connection name to this environment variable? db pass, db. What the fuck? Where do these come from? Like this does not seem like a proper way to do that. Do we need to provision ourselves the users? So resource Google SQL user. And that's going to be our functions user. And that is going to be for the default DB, and that's going to be on a thing, and random password, and that's not going to be the root. No, no, no. Do we need to? Okay. Google time. We are going to just figure out how do we call this thing correctly. So Google SQL user, that's going to be me. No, that's going to be service account user, or the compute service account user. Note for Postgres only, GCP requires omitting the .gcp.gservice account suffix from the service account email due to the length limit of database usernames. This is such a crying shame, like that databases still have so much legacy that they do not, that they cannot do that. Anyhow, I'm getting really just, I'm making a lot of noise. So we've got an instance, we do need a name, password for the instance. If we're not using the password, then don't set this field for Cloud IAM user and Cloud IAM service account user types for any Cloud SQL instance. But wait. I'm confused. Changing this forces the resource to be recreated. That's all right. Name the name of the user. Changing this forces to be created. That's again interesting. Yeah, fuck that shit. Let's just generate ourselves another random password. So resource random password. By the way, yeah, sure. Let's just continue with random password. Maybe let's go with random random ID, integer, random string. What was that? Random ID. Yeah. Oh no. So random password seems okay. That's going to be functions user password length 20, and that's going to, let's actually just keep that something like in the same, I don't know, 8 bytes is more than enough. And that's going to be the functions password. Yeah, just result. So we are provisioning ourselves a user, and we don't need any root user. So let's just keep that going and apply. This feels very slow. So two things that are going to be added is the user and the password. Okay, completed. That was quite easy and fast. Now the question remains, how do we inject these into our environment? Let's go back to the configuration and figure out if we want other things to happen here. So security and image repository, not connections. Allow all traffic. Yeah, build, nothing fancy. Runtime, nothing fancy. Where's the, like, I want the cloud connection, cloud SQL connection thing. Maybe we'd want to push that password into our DB to the secrets manager. Seems like quite a lot of work. So connect. So is that like a MySQL thing? That's well, it is getting late. I think we need to actually bind that to a secret. So let's create secrets. Resource, Google, secret, manager secret. And that is going to be, that's going to be our function user password, secret ID, function user password, interpolated with our SQL instance name. Secret ID, yeah, that's the one. Or actually, let's just verse that thing. So yeah, that's a long name for the right thing. Actually, you know what? Too long. SQL functions user password. Yeah, good enough for now. And the value, that's going to be revision with ID, 5-time replication. Where's the actual secret? Rotation, provider. Google Secret Manager secret. So this is how we create the secret. How do we actually inject the secret? Logical secret whose value and versions can be accessed. Secret ID, secret labels, annotations, replication auto. Replication auto seems like the right thing to go here. But how do we set the value? I'm basically aiming to bind this the password to the secret store, and then we can just extract that on the function without like managing the deployment of the function through Terraform. So that's replication. Is that the only thing that we can do here? I'm quite surprised. Data source. Secret version. Ooh, that's the one. All arguments, including potentially sensitive values, will be stored in the raw state as plain text. Payload secret data. Read more about sensitive data in state. Yeah, so the bucket is basically just owning everything here, and so I'm not worried about that, not specifically, and also like not now. So secret version, yeah. I see. So this is basically defining the storage of the secret, and this is now the actual revision of the secret. Which is this one. And the secret data is going to be the result. That's how you define that. Yeah, secret data. And we could, I think, use like customer managed secret encryption key on the bucket. But that's not going to happen now because the bucket is unencrypted at this point. But yeah, this encryption key is basically like should be the magic stuff that allows us to also encrypt the bucket state, which we're not going to do now. But just so you know, it is possible to like have everything be encrypted. Anyhow, we do have our secret now. Let's just provision that and generate that. And let's apply. I'm betting this is going to say the secrets API is not enabled. And it is correct. So let's just go to the project, enable the secret manager API. This is going to also cost a few more cents because Google really do love the smell of money. And while this is happening, we can already apply with, oh no, stop. Operation canceled. Yeah. All I wanted to say is also auto approve. I do not want to like waiting for that. And this is going to say at least one of the preconditions. Yeah. We need to unlock this. So Terraform force unlock this timestamp. Yes. And let's try that. And hopefully we have not broken our state completely. This is what happens when Terraform is so slow. Okay, so secrets are there. We don't need them anymore. While this is happening, apparently already happened, we can now go to our runtime environment variables and let's bind a variable. Why can't we just use this correctly? Next. I really wanted to like let's deploy that. I know it's broken. Oh, they deleted the code. That's also bad and unnice of them. But anyway, I just wanted to wait for the first deployment, and now we can edit everything while this is actually happening. Powered by Cloud Run. I do not care for Cloud Run right now. Cloud deployments suck. I don't know what to tell you. Things are super slow in the cloud. And the only thing that I think makes it better is to, first of all, suffer immensely by having your own cloud within a cloud in your Kubernetes cluster, and then you can deploy to that cluster whatever you want in seconds. But deploying everything through Google is just so painfully slow. So this is building, this is taking a while. Come on. All I want to do is edit the deployment. It just give me a way to edit the code. Can I edit here? No, this is read only, of course. So yay! Okay, it's editable. So right now we are here, add variable. So apparently I cannot use the secret manager. Do I need to like bind everything something to make that work? Secret reference. Thank you. That's the one that I wanted. Yeah, so grant mounted as environment variable. And our variable name is going to be, well, SQL password. That's going to be, yeah, the version 1, latest basically, and done. So that wasn't so hard, wasn't it? I mean, it was, but yeah. Okay, so we do have our password. Now we also need to reference the actual connection somehow. So let's figure out how do we bind that. Also through Terraform, I think right now we are on the right direction. We can basically bind more secrets quite easily. They're not really secret, but it is a nice way to communicate that we can just like update that and like through the secret store and everything will propagate correctly. So infra abuse, Google Manager secret. And this is going to be the SQL connection string. That's going to be SQL connection string. Replication, nothing, I don't care. Then resource, Google secret version, what was that? Secret version, yeah. And this one is going to be our, again, SQL connection string and secret, same shit, secret data, connection name. I think that's the one. And now we can actually run that. Terraform apply, auto approve. Yeah, by the way, this is definitely not a versions.tf file. This is basically just the whole deployment in a single file, single module. Usually you're not supposed to do that, but cool. And it says secret version got HTTP response 404 doctype HTML. What? Say what now? Connection name, default one. Is that not a thing? Connection. What? Let's go back to our SQL database instance. Right? It should be the instance, not the... Yeah, it's the instance. And now if we go to our actual attribute references. So IP address, self-link, connection name. The connection name of the instance can be used in connection strings. For example, when connecting with a Cloud SQL proxy. Yeah, so that's the one. So connection name is definitely the right one. And we do not need this one apparently. Do we? Or do we not? I am confused. Error, not found. Google logo. That's an error. Yeah. Was not found. SQL connection string, add version, JSON. Did I fuck this up? I did. I did fuck this up. Yeah, so that's still okay, and connection name is the thing. So let's continue with our terraforming. Should be quick, and we should be able to bind that secret in a minute. In the previous window, if we go back to this one, security, and bind another secret, and which secret it is the secret that's still not discovered by Cloud Functions, which is making me a bit sad. But enter secret manually. Why is that? Why do we need the secret manually? Maybe I want to actually have an output block, which is going to be the SQL connection string value, whatever that thing is, and also the secret name. I don't want the secret ID, I just want the names. So that thing, basically. Password, secret ID. Yeah, the secret ID and output. So not the connection string, I just want the connection secret ID again, and that thing. Let's just run that. It should just output everything with no changes because there are no changes to the infra, just to the state, which is that one. So we got our password and our connection string. So let's just reference this one. That secret. Yes, please. Let's grant access. And this is going to be an environment variable, of course, and that's going to be SQL user, or sorry, secret connection. Version 1, latest, done. And another secret that we are going to use is the user itself. So let's figure that out as well. So by the way, I like provisioning secrets from Terraform. This is actually like not a terrible thing. So secret, that's going to be our function user secret ID, SQL function user, replication, sure, same thing, and resource secret version, functions user, and the secret value is going to be the ID and the user name. Yes. So that means we are completely auto-provisioning our user and our secret to the user. And that is nice because that means we don't need to like pass sensitive data around. We can just compute it through the end variable variables. By the way, mounting to a file is probably more secure than using environment variables, but really, I do not care at this point. So SQL functions user mounted as environment variable. That's going to be the SQL user version latest, done, next. So we've got ourselves a SQL user. That's going to be os.environ. Let's just write that in, PyCharm. So that's going to be function. So let's just import OS, and that's going to be SQL user, SQL password, SQL pass, SQL connection. Yeah, that's not a thing, not here, but how did we call that? We have a nice name for that. Security. So SQL connection. Okay. Do we actually know how that secret, what's the value of this connection? I think we are allowed to peek at the secret right now because, well, not interesting that much. Secret manager. So secret connection string enabled. Action. View secret value. Okay, so that's Soup's infra, blah, 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 blah. And that's going to really be useful with the Cloud SQL connection with functions. So this one. So we've got our DB name, our DB pass, and our instance name. So we've got our instance connection name. Do we know how to connect that without MySQL? Instance connection name. How does that look? Making sure that basically this is the, oh, actually, no, that's exactly what we have because that's an instance connection name. This is exactly the secret that we're using. So how do we reference that in PsychoPG? So PsychoPG, Cloud SQL instance connection. So database Postgres user, whatever the user, host Cloud SQL MyNewDB. That's not working. And then they say Unix socket, Cloud SQL format this thing. And then with the database user host Unix socket. Okay, seems good. So let's just use that because apparently that's format SQL connection string. Yeah. And where's our PsychoPG? So let's just import PsychoPG and let's pretend everything's just working with just writing PsychoPG, not install, but the basic module usage. That's the one. So with all of that, connect. Let's install PsychoPG on the right thing. So write add psycho write sync. And also just for good measure functions framework. And while that is happening, let's figure out how does the connection thing look like. So connection info, is that just a string? That's it? Wow, that's quite sad. So yeah, okay. So let's just interpolate things into that string apparently. So let's just restore that and figure things out quite quickly. So we've got our password. That's going to be SQL pass. That's going to be SQL user. DB name is going to be default DB because that's the one we created. And our SQL connection name. Psycho PG 3 Unix socket. Host, apparently. Psycho PG3 host connect. Ooh, okay. Looks. Oh, that's a PsychoPG 3 driver. Yeah, okay. So psychopg.connect database equals database ID, host, localhost, port, blah 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 blah. Ensure the PG adapter that PG adapter is running on the same machine that is the application using the Postgres PsychoPG driver. I am confused. That like running for cloud functions? I really hope so. Connect con info string. Con info. So we can use user Pierrot, and that's going to replace Jeff. Okay, so we can pass keyword args or connection info to dictionary. Connection string. Let's just figure this out. So we do need host. So let's just run the host. So this is going to be just that, I guess. DB SQL connection name. I think that's it. Okay, let's just pretend this is working magically. I really do not know if that will just work. And now that this is basically connected, we don't care about the request, but let's just let it pass. Let's copy the example from the docs of creating everything here. So let's just open the connection, do something, and whatnot. That's going to be if not exists. And that's going to insert something, and we are moving on. Open a cursor. Yeah, sure. Cool. And I just wanted to return the record. Let's just try accept done. No records. Yeah, sure. That's going to be name error and or unbound local variable. So unbound local variable. Okay, and that's a string. Let's just paste that into our function. Next. Okay, everything here is bound. We can paste that in. This looks good. Let's just add psychopg to our requirements. Let's look at main.py. Nothing fancy here, nothing interesting. Yeah, we can just go on. And this deployment is going to be the last thing we do. If this works, then basically we expect that unauthenticated calls to this function will just work magically. I'm not sure if this is the case, then that's not as bad as I thought it will be, but it is quite bad. The amount of suffering we had to go through to just provision database and connect up our user and password between one function and one DB. Okay, build finished. This is still surprisingly slow. Slow indeed. And we are going to see 500s apparently. So yeah, let's go look over the logs and figure out what the fuck just happened. And where's the error? Yeah, handle exceptions. PsychoPG connect. And it says operational error. Connection is bad. US Central Cloud blah blah address. Name or service not known. Yeah, because apparently I did not do the right thing, which is to give the Unix socket. So let's just edit the code and redeploy. So next and paste. Now with the Unix socket in the right place. Apparently, wow, so the editor in this crappy page it does not even support F strings. Wow, okay. Google have not tried hard at all to keep this up to date. I wonder how many committees do you need to go through in Google to change this page? And let's invoke a request. And another 500. Who would have thought? Let's see. Why are we sad today? Operational. No such file or directory. Is the server running locally and accepting socket connections on that socket? The answer is probably no, but we are going to figure this out shortly. So let's figure out how do we actually connect cloud functions. Because winging it didn't work as we expected it to. So configure cloud function to enable Cloud SQL connection instances. Confirm that the instance is created with above has a public IP address. So the instance does not have a public IP address, but we do have a connection string, connection name. We are using second-gen cloud functions. The following are required. See also configured cloud run. Follow the standard steps, in which case, okay, so yeah, this cloud function is fake. What we do have is our DB writer right here and the cloud run, which basically is wrapping a cloud function. So in this area, we do need to add a Cloud SQL connection, and that's going to, and we need to enable the admin API apparently, which somehow we did not need to enable up until now. And let's just have that connected here. And we can now deploy that. And this revision is going to have everything the same, but we actually just yeah, basically yeah, we have now bound our Cloud SQL instance to our function, but not to the function itself, but to the thing that's serving the function, basically. Yeah, and we can now go back to our function itself and our upstream request timeout. And here it is timing out as well. Interesting. Let's go over the logs right now and figure out what went wrong this time. And it is saying, default startup TCP probe started and succeeded after one attempt. DB writer on port 8080. Cloud SQL connection failed. And, oh, interesting. Please see connect run for more details. To Cloud SQL 0203, blah, 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 blah. Create a new revision, and subsequent revisions automatically receive the Cloud SQL unless you explicitly change that. Okay. But if we have a private IP, do we need anything fancy, or can we maybe do that in another way? So a serverless VPC access connector handles communication to your VPC network to connect directly to the private IP. Make sure that the Cloud SQL instance created above has a private IP address. Configuring a private IP page. Create a serverless VPC access connector, blah, 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 blah. Private IP. Connect to Cloud SQL. through Unix sockets. Echo PG Unix socket. Host. Host equals /temp. So it's definitely failing. Wait, why is it docs MySQL? I'm not trying to connect MySQL, but apparently that's the only thing that's documented, not Postgres. Oh, I can go here and ask for Postgres. Okay, so we have enabled the API, we have configured Cloud Run. Okay, I'm feeling like this is going to be too long for this to debug, for us to debug before midnight. I'm giving it like 10 more minutes if we can't figure this out. Ooh, interesting. Instance connection name / this one. That's peculiar, but I believe we can try that. If this will do, then I think we might be on our way. So this is going to now be Cloud SQL project region instance. How did this look here when we looked at the secret? This is the name of the project, the region, the name of the instance. Compared to our project. No, okay, so this is okay, project region instance. So that's the Cloud SQL connection name, and then they say the Postgres standard requires a .pgsql 5432 suffix to the socket path. Some libraries apply this suffix automatically, but others required to specify the path as follows. And query Unix sock. I'm quite convinced that PsychoPG knows how to use the Unix socket, but that's like crazy talk from my end. Features home. Documentation. Unix. Okay, so Unix socket. Host. The server host name. Yeah, this is basically probably the connection info. Okay, so host. PQ host. Can be a hostname, IP address, directory, path if the Unix is a Unix socket. The path case can be distinguished because it will always be an absolute path, beginning with a /. Okay, so /, yeah, that's just the thing. Okay, so let's figure this out if adding this actually solved anything. Probably not, but let's redeploy and hope for the best. Next, and paste everything in, and I test the function. Test your function before deploying. That's nice. I didn't know I can do that. That's quite a nice thing. That's, ooh, that's really fun. Starting testing server. Please wait until your function is deployed. But this is just going through the deployment process without creating a new revision. Okay. Okay. This is like points for Google for making this nicer to debug. Cloud function is still initializing. Building function sources. This is taking a while now. Wait, did I bind these services correctly? If we take a look at the logs themselves, if we go back to the console and go through functions, writer logs. So we only see Unix socket here, but we do need connection is bad. We do see. Okay, so US Central connection refused. But that's actually before our actual use of the Cloud SQL thing here. So that is, oh, yeah, of course, authorized. I mean, I opened it. I believe this. Oh, and it says keyer SQL user. Yeah, okay, so apparently I fucked up and I have not bound the right environment variables. So that's an easy fix. Continue and close. So let's figure out what did I do. So it's SQL user as environment variable, secret SQL connection, and SQL password. And these are n variables. Okay, continue. SQL user, SQL password, SQL connection. They all seem fine. And I'm not worried with printing credentials. So let's just print everything because who fucking cares about security right now? We just want to go to sleep. And let's run the test. Test server starting. Please let's just let the print run quickly. Building function sources. As if there's sources to be built here. It's 48 lines of Python. Fuck that shit. I'm going to deploy. Testing in production is tight. At least I limited things to run for no more than 10 seconds because apparently when things hang, they hang. And that would have led to 60 seconds of billable compute time for just debugging the simplest connection string. Um, And let's open that, and at least it's a quick 500 and not it's not hanging. And we are now seeing this error, and it says connection US Central blah 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 bad. Okay, so first of all, seems like PsychoPG already added that, so we don't need to add that ourselves. But where's the goddamn /cloud SQL here? I'm surprised. First of all, let's just interpolate this crap into this crap, and we don't need this suffix. We don't need to format anything, and we can now use the Unix socket directly, which apparently we already did that. Our SQL path, SQL user, SQL DB, and it says not a directory. And it is not a directory. That's correct. Let's just copy and, by the way, functions, user. Where's that goddamn slash Unix slash Cloud SQL thing? Next. Paste that. Deploy. We are waiting once more. If this ain't working, then we are going to enable like a public IP thing for the SQL instance, which we can actually do that in parallel, because why waste our time on not doing that in parallel? So SQL, let's add an IP for this private instance. And edit. Probably connections. Working, private IP, public IP. Enable private path, yeah, and save. And while this is running, this is deployed now. Hopefully this will just work magically, right? Request timeout. Shit. Why is it timing out? And it says connection string bad. And I say, where the hell did the Unix socket thingy go? I have definitely passed it in. Say what now? Cloud SQL connection failed. So first of all, apparently they do know that I want to run a Cloud SQL connection. Timed out after 10 seconds. Interesting. So it's timing out on the instance. Create connectivity test. Do we want that? We do not. Overview. We don't want to clone anything. We've got an IP address, we've got our service account, we've got, we need to add like permissions. Probably not. This would have been a 403 if that was the case, or whatever the equivalent like in Google's world. Databases, default DB, char set, yeah. Nothing interesting here. Use those. We've got our functions user, and we are probably using it. Query insights. Nothing here. System insights. Key connections. 3 connections. Interesting. So it is erroring or alerting. 3. Usage cache. Automated backups disabled, not highly available, zonal. I don't care about that. Edit configuration. Single zone. Interesting. Fast. Yeah. Connections. Data protection, daily backups, maintenance, no, not interesting. Flags, query insights. Authorized network. So you can specify a CADR range to allow IP addresses in those ranges to access the instance. You have not authorized any external network connections to the SQL instance. External applications can steal the instance with Cloud SQL proxy. And if we, yeah, I do not want that because, well, we don't want to expose this instance. What the hell? No records found. Interesting. Woo! Okay, so it was just about like taking more time for the DB to initialize, or is it the public IP address? Let's just remove the IP, save that, and we can now refresh away with our function, which is, by the way, taking quite a while to actually run. If we actually look at the networking, then this is taking a while. And yeah, okay, so it is only for public IP things. I wonder why. Okay, so that's the IP currently. But why expose the public IP? I'm confused, but okay, so but there we have it. Like we can run queries against this database. It was just horrible to set up and horrible to configure, but we can do that. It's still editing, so I cannot actually disable that to show you again. But yeah, basically, this function now no longer works when we disable the public IP again. So yeah, so this is failing. This will fail every test, every 10 seconds, and then once this is actually finished, we could re-add the public IP and then expose that thing. So yeah, this is now supposed to be still failing, and I will now add it, add the public IP again. So let's assign it a public IP. Save. And we can now run our function, and at some point, once like all the provisioning will finish happening, we could actually just move my face on this and transition. Yeah, and at some point while this progress bar is running or after it finishes, we will be able to actually rerun the function and access the DB again. And that's it. And now we can actually run multiple requests, and we can advance the counter in the record because we are always apparently pulling out the latest record from the DB. Okay, so that was horrible and cool, and now we all know if we wanted to, We all know how to deploy a DB in GCP and connect to it via Cloud Functions with their Unix fake socket. And hopefully, I'll see you in the next video where we, I don't know, maybe do something else completely, which is unrelated to this one. If you like this video, then please let me know in the comments and give me ideas for what other videos you'd like to see for, like what other videos you'd like to see. Yeah, bye for now.